Hello, I'm Steve Johnson. Welcome to Digital Works TV and another special guest, Joe Fitzgerald, who for 10 years until 2023 was a civilian aide to the Secretary of the Army for North Alabama, essentially for Redstone Arsenal. And are you emeritus?
I am an emeritus.
You are an emeritus.
That
That means they didn't want to let you go.
Well, that is an official title. As it turns out, the civilian aides to the Secretary of the Army are term limited. They are congressionally authorized, but they are term limited to 10 years. You can serve 10 years. And so I served 10 years.
You served your full 10.
Well, it was 2 years at a time. They renew you every 2 years. But I served my 10-year limit, and so not everyone gets an emeritus or becomes an emeritus. So I'm very proud of that. I am
you should be.
Civilian aide to the Secretary of the Army Emeritus.
Okay, so
And that's a lifetime.
So, can I get the short version of what the heck an Assistant Secretary of the Army, civilian aide to the Secretary of the Army for North Alabama does?
Well, in a short version is you're the.
You can give me as long a version as you want.
In that post, you serve as the personal representative of the Secretary of the Army. Wherever the Secretary is not, and you are their personal representative. Okay. If they're there, you're there. You're assisting them in understanding the circumstances under which they are there. Now, I had very fortunate to have brought into North Alabama and Redstone on several occasions the currently serving Secretary of the Army. Yeah. But another aspect of the civilian aid is that it's a two-way communication. We are their eyes and ears in the markets and the geography we serve. My geography was Birmingham North to Huntsville, and as you might suspect, all civilian aides to the Secretary of the Army do not serve the same op-tempo areas. To your point about Redstone Arsenal, with 15 general officers and a 4-star headquarters command and a direct reporting 3 stars with RICTO and Space Missile Defense Command, for example, and many things. Just as a federal campus, we're very robust. So it is very demanding in terms of the two-way communications. I provided information to the Secretary's office, and the Secretary provides information to the civilian aide to carry that message to the leadership on Redstone. So, and I had the good fortune to have worked several major issues that I'm very proud of while serving as civilian.
Oh, yeah, well, it's one thing about it is when I was at Channel 19, covering things, I saw you a lot.
Yeah, I was there. So, my job was to be there.
Okay, so but we're going to talk some about what you did before that. Yeah. But what are you doing now? What are you doing since even though you're an emeritus and you get called in, you probably are doing something else.
The thing that you might also understand, find a little interesting, is that the civilian aide to the Secretary of the Army is an unpaid post. You are unpaid, although you are equivalent to a 3-star general.
Well, wait a minute. My sense of it was you were working all the time for that, and it was unpaid?
It's unpaid. And as emeritus, of course, you're unpaid. So I was unpaid for that entire period of time, just like Elon Musk. I mean, we were SGEs. We're special government employees. We served 120 days.
Did you start out as a billionaire
SGE.
when you went into that?
Well, I was not a billionaire. I shouldn't say that. I would have liked that, as a matter of fact. That would have been nice. But at any rate, that being said, I was an SGE for 10 years, special government employee. I served at the behest of the Secretary and served well, tried to serve well. But I don't know, lost my train of thought. Go right ahead.
Okay, so what are you doing now?
What am I doing now? I've always been, since 1994, I left Teledyne Brown. I was director of advanced programs for Teledyne Brown when I left in 1994. I started a consulting practice, and I've had that consultancy for 30 years. So I have been a consultant for 30 years, supporting clients. I've had many of my clients for the 30-year period, in which I've been a consultant. So I still work very, very hard every day as a consultant.
Okay, so
helping my clients navigate the government contracting environment, as well as solve technical problems and work issues associated with their whatever engagements they are.
Well, it's one thing. You could have done that job. You're a systems engineer by training, correct?
I am a computer scientist by training. Math, my undergraduate's in math, graduate degree in computer science, doctorate degree in systems engineering.
Okay, so you're okay.
I'm a computer scientist. I'm a recovering computer scientist.
Okay,
I'm a techie.
You're in the systems engineering world, and I've got to believe. It's one thing. I don't know how up on technical issues any Secretary of the Army is, but around here, if you're not up on technical issues. It would have been tough for you to do that job without being knowledgeable and proficient. I mean, you wouldn't be able to do it, would you?
Well, there's a lot of truth to that. I mean, just like we tend to characterize business developers and things like that, and folks that are out here in the marketing space. But when you get into the marketing and business development and advanced programs, research, R&D, for federal work that we're engaged in, the highly complex technical environments that we're engaged in, you need to understand the problem set, understand the solution set, and be able to represent that and to a customer, and work the issues associated with their understanding that. That's sometimes the most difficult problem.
Yeah. And it strikes me, one thing, you are obviously satisfying the Secretary of the Army. That's where your responsibility is, but don't think you would have kept the job if you weren't making all the various agencies and companies and clients you were working with feel like you understood
Absolutely
what they were doing.
Yes.
Because I've been around these guys. You got to know some stuff to do that. Mm-hmm. And so I'm assuming that your computer science and your engineering kept you on the job.
I would hope so, and I agree with you 100%. You have to understand the environment in which you're working, and that means have a technical understanding. Now, you might not be able to, and this is something that I reminisce on, because when early in my career, when I moved from Huntsville to New England for a number of years, I was running a large supercomputer center here, built it from scratch in Huntsville, and several of them, and I was director of software engineering here. Was a leader in computer science and software engineering and modeling and simulation here in North Alabama. And I went to PerkinElmer and became, I'd become, during the course of your career, and this is inevitable, it seems, as you proceed through your career, you lose your technical prowess. You lose the ability to work at the journeyman level. And I resisted that for a long time. I did. I tried to maintain that edge. At one point in time, I was a member of 28 technical societies. And I mean, that's a lot of dues, but I was also a leader in many of them.
Yeah.
And I could go through all the litany of those, at NDI, IEEE, and IT, and all of them. I was a leader in many of them, and very proud of that. Very proud of the fact that I was trying to maintain that technical edge. But as you move forward, you can't maintain that. I could not, and so you move into management, you move into leadership. But to your earlier point, and the point of this discussion, the maintenance of the understanding of what those folks are now doing and being called upon to do, and what those tools did, and so on, it's very important. And I think that it was very important and helpful, and it continues to be helpful for me to have that technical background, to understand my technical the customers' issues, problems, and my clients, my companies I represent, their solutions and what they do, and what they bring to the fight. Is it
hard to keep up now? I mean, even now, is it hard to keep up because things. When you started doing this, yes. AI was it was out there, but it wasn't like it is now.
No, it's not.
And any number of other things.
It's interesting that you mentioned AI. Back in the 1984, when I went to PerkinElmer, we worked for a number of classified programs, and I had 3 AI labs at that point in time that I was responsible for. I was director of software engineering and deputy director of engineering for PerkinElmer Optical Group, and it was involved in many programs. And I had 3 AI labs going on, funded by R&D, and so, but there were limitations on what we could do, obviously with computational power available at that time, and but we've come a long way to your.
Yeah, it's changing.
It was in its infancy then, but it existed. We knew it. We knew what it was going to be, even then. But what it's become and what it's going to become is pervasive.
We could have a whole 30-minute conversation about that. I mean, I even have chats with people outside of this about AI and about their use of it, and I get it, but it still worries me a little bit. Okay, so you're computer science, and so, but you told me you've also worked for NASA. You've done a lot. You did a lot of things that qualified you to do your civilian aid job.
We would have a much longer podcast if we went through the litany of my career and where I came from. But I began in 1968. I worked for a contractor in town, Computer Sciences, in the computation laboratory at Marshall Space Flight Center during the Apollo program.
Yeah.
And I later became the responsible for the.
You were like 12, right?
I was, yeah. I'd like to think I was. Actually, I was 19. That was back. Okay. I was before I graduated from college. I started.
So were you a co-op student?
I was not. I worked full time and went to school at UH full time and graduated in 4 years, by the way, which is astonishing at the time. And when I think on it, I don't know how I did that. I didn't sleep.
Just so you'll know, Jan Davis got her master's and her doctorate working full time at Marshall, going to school at night. And when I talked about it, and it didn't take her any extra time. Of course, she already had 2 other degrees, so she was used to going to school.
Right.
So, but it is amazing what motivated people can do, and obviously you were motivated.
And I was young and energetic and so on. But I became responsible for the models of the trajectory simulations for the Saturn 1B and the Saturn 1B and the Saturn 5. Those during the flight analysis section of the comp lab. So I like to say I personally define what sneakernet means. Sneakernet.
Well, you're going to need to tell me right. What does that mean?
We ran sneakernet means obviously when you have a network, it's electronically connected. People normally think it's electronically connected, but back during that era, we did not have electronic connectivity. We had telemetry came down in A-wing came down through a teletype, and you ran to the teletype and tore off the tape, and then ran to a punch card machine to type the state vector of the vehicle in flight, so that you could put that into a deck of cards and run that deck of cards into a card reader. And
that sounds like that thing that business did, Fortran and COBOL.
I was Fortran programmer, absolutely. But yes, and run a simulation to see how the vehicle was performing. Well, that's what you did. But you literally ran.
Yeah, I was going to say, was that...
I ran from A-wing to the teletype, or to the punch card machine to put that state vector into coordinates into the punch card system so I could run it. But that's sneakernet. That's sneakernet.
Sneakernet.
So, because you got your sneakers, you got your sneakers on.
Okay, so that's pretty cool. I've never heard that before.
You got your sneakers on and you're running.
So sneakernet. Okay.
You're running from point A to point B. That's the network. That is the network.
So guys who would have been the equivalent of systems engineers, or just engineers working on a project, and you more than likely did this too, were used to lots of paper and draftsmen. If you were at Marshall in '68, you remember those
boards,
those pictures of the old Huntsville Industrial Center, the Hick building with the room full of draftsmen, and you could go out to UH right now and look at the blueprints of the Saturn V.
Yes.
So there was everything was on paper, or they were using sneakernet to do tests, live fire tests. So
I've got my own stories relative to the boards, but I do remember literally the field of boards. And I say boards, these were draftsmen's boards. Yeah. These were draftsmen. These were, many of which were quite skilled.
Oh, no, yes, I've seen that.
Designers and draftsmen were quite skilled. And I have my own story relative to that because, while at Perkin-Elmer, and while I was...
what is Perkin-Elmer, by the way?
Perkin-Elmer is the name of a company, Perkin-Elmer Corporation. There was a computer Perkin-Elmer at the time. But it is a company, it was based in New England, that did business all over the world. But I went to work for them, and then I came back here in the late 80s. But I went to work for them in the early 80s. But I transitioned a large 100 draftsmen and designers from boards over very painfully to CAD/CAM, to computer-aided design, computer-aided manufacturing, to CAD.
And when was
CAD
that week?
That was in 1984.
Okay, and
In 1984, Intergraph was started. Didn't start. No, it started much earlier than that, quite frankly. And I knew Jim Medlock and Nancy, and I worked closely with them. As a matter of fact, we're on their campus now, their former campus now. But I purchased those systems for PerkinElmer, those CAD systems from Intergraph. It wasn't called Intergraph, or they changed their names at that time. But it was M&S. Computing, M&S Computing, which is the predecessor to Intergraph, and we bought those systems and went about the migration of those, because PerkinElmer was the prime contractor for the optical telescope assembly. That's what I went up for. One of the reasons, optical telescope assembly for the Hubble Space Telescope.
Okay.
So Lockheed was the prime. PerkinElmer was an associate contractor. It built the optical train, the primary, secondary mirrors, all the instruments. Yeah. All of that was PerkinElmer. Yeah. So we were transitioning those design drawings over to CAD from paper.
Going digital from paper.
Going digital indeed. And that is a very painful and laborious exercise. Not everyone, of course, these craftsmen, some of them were quite up in age, were not suitable, you might say, or it was not conducive to do that with them. They did not want to do it, and then you have others that are quite receptive to it. You have to take those that are receptive to change and embrace that and go forward. It's sometimes a bridge too far to take the other, and to try to push someone into that's resisting to not go that direction. They just some resist, and it's just natural in anything. It's natural in what we're doing now with model-based systems engineering. Some people resist, and it's quite natural. They're used to the way that they've done it. I hate to use the term "always done it," but the way that they've done it in the past. But
even them, if they've been in it long enough, they did it another way before they switched to the way they're doing it.
Yes, but there are natural migrations, and there are stepwise or revolutionary steps that you take. Yeah. And that's what we're engaged. We tend to be engaged in that from time to time, making those revolutionary changes to leapfrog technology.
So I got to believe that the fact that you're familiar with all the different ways it's been done into going all digital or whatever it is now, that's given you a little bit of wisdom in your consulting duty.
I hope so.
Doesn't it? Because you can say, yeah, I get it, but. I mean, you can say, do you ever say that? But you need to be moving in this direction. Do you ever say that?
I do. I try to help my clients move in the right directions, and so you're quite right. But also, it's equally good to advise them when not to do so, or how to do it, because many folks will take on these revolutionary changes in many companies, and engage in it the wrong way, you might say, in terms of how they're investing and forcing, mandating. Forcing and mandating are not the way to affect change. It has to have value. It has to have the change that we're embarking upon and have embarked upon relative to these advancements in digital engineering are because they make the job better and faster and more economical or more financially viable, or that you can see things earlier, which saves some time, energy, and money. So it all boils down to time, energy, and money. And if you can make this a value proposition, it will sell itself. But if you have to sell it through mandates or edicts, it will not, and there will be resistance. And so when I get into these discussions with folks that are marching down this path, I say, well, where's the value? Where's the where are you saving time, energy, and money? Cost savings and time savings, and building a better system. That's what this is all about. Building a better system, and doing so faster and more economically. Doing it, and if you can solve those kinds or answer those kinds of questions, they'll be beating down the door.
Okay. So you show them the light, and then they take it from there.
Yeah.
Okay. So, and you've already mentioned model-based systems engineering, and so that is we interviewed Jan Davis, the astronaut, not too long ago, and she was talking about how when one project she was working on at Marshall, it was all these meetings because they weren't able to do it digitally, and she was so basically she was before model-based systems engineering, all digital. She was doing other stuff and not working on that, but she said how nice it would have been if we could have skipped those meetings and been able to see how change to A changes Z without having to have people fly from all over the country or whatever to talk about it.
Yeah, I've had that same experience. Obviously, when we were working on a number of things over the course of my career, I've had the identical experience of endless meetings, endless travel, endless interactions, and well, let's just fundamentally describe the way things were and how they have been. I mean, throughout history, we've built models.
Yeah.
We've built models of things, but we've built them. And we've built them out of various materials and so on. We've built them in one form or another. And then during the advent of the early computer era, we started mathematically describing those models and replacing, in whole or in part, pieces of those models. During the course of since the 70s, 80s, 60s, 70s, actually 60s, maybe even in the 50s, but I'll say in the 60s, certainly in the 60s.
You were 4, so.
But I mean, all the replacing pieces of them, and now, and over these many years, we've now gotten into the situation where we can represent an entity or a set of entities in the context of a digital representation or a model, a mathematical representation of what it is. And now we've also evolved over these years in something we've become quite good at, and I venture to say that is our future, and that is a requirements model or a requirements language, and that is unambiguous language, unambiguous description of a process or an entity. But anyway, getting on, we now can represent a system in a mathematical form. So, and we can exchange hardware or pieces of hardware or other mathematical forms, either one, with subsystems and with portions of that model to determine, as you described, the changes, what effect it had or performance it has. So these are hardware in the loop systems. These are sometimes they're entirely digital. You don't have to have the hardware. But as the hardware comes along, and this is the way these systems are developed, when we develop a new rotorcraft system or a new uncrewed system, uncrewed aviation system, uncrewed system of any sort, a robotic system, or uncrewed, and when we develop a new system, we can develop it digitally, entirely, and run through and where you can change things rapidly, and see the effect, improvements, and we can test, we can innovate, we can do all this without bending metal, without going through that process. And we can also do this, and what I enjoy about this is we can do this in parallel to production, limited production, early production, early prototypes. Bring in prototype hardware, bring in early production hardware, bring in new modifications, such that you can do this in parallel and bring along and exchange the digits, the models, for those pieces of hardware. We used to call that plug and play. We'd plug it in, we'd plug and play, plug pieces in, and so you eventually complete the entire system digitally and manifest itself in actual hardware. And you maintain that digital model, and many organizations have hardware in the loop, very sophisticated hardware in the loop systems, and combined with digital with digital twins, digital models, and that is used, and that's why this is so important. That's used throughout the system life cycle to develop. It's used initially to design and develop and test, all the way through a life cycle of a system. When I say the life cycle, a system that we know today, for example, I mean, gosh, the CH-47 has been around for 50 years.
Yeah.
B-52 has probably been around 60 years. And these are systems that, although we call them B-52 and CH-47 or Chinooks and so on, or we call them that, they they pale.
They have evolved.
They've evolved. They're not what they're
Yeah.
not your granddad's CH-47. That's not your granddad's B-52. It's called a B-52, but the mod of that B-52 is its digital cockpit. It's this composite fuselage. It's the whole. Those things. When we talk life cycle, we're talking about the continuum of modifications, improvements of these systems throughout the course of their useful life.
Yeah.
And to define what their useful life is, I mean, in that environment, it could be into perpetuity from practical standpoint, because their useful life is a continuum of process of where they replace themselves. Yeah. They're replacing themselves in terms of this. A digital model will evolve over time and will be with us and is to be used throughout the life cycle.
And it is so much easier doing it digitally than it would have been upgrading the CH-47, having to have a bunch of meetings. And now,
well, I don't know about easier.
Well,
but I'm going to use a different. Yeah.
Well, I mean,
it is
not easier, but less laborious, less.
It is. I'll just put it. It's better.
Yeah.
It's better because it's you can change it.
Yeah.
You can change it easier.
Yeah.
You can test it easier. You can validate it easier. You can determine what its advantages or disadvantages. Now, it has the added feature of I can implement a change in a digital model and get an adverse outcome.
Yeah.
So I know I shouldn't do that. And now when I do that with I've got a piece of hardware. A piece of connecting bracket of some sort. To actually implement that in a hardware test, I might have a catastrophic failure. But at least
if it fails,
if it fails, I can.
Yeah.
Well, I used to have the expression in IT, and I still do. I chair the Space Missile Defense Working Group for NDIA and have for the last 15 years or so, and I really love that. Love that because I believe that, and we've advocated for many years, to test often, test early, and fail early.
Yeah.
Test often.
Now, I've heard that.
Do not be afraid of failure. Now, that's a hard nut to swallow for a program manager, to fail. And don't be afraid of failure, because they are. But in a digital environment, that makes that practical. Yeah. It makes it practical.
It doesn't cost a whole bunch of money to test digitally.
No, as a matter of fact, you can test a lot.
Yeah.
A lot, and test and fail a lot. Test and fail a lot. You learn a lot more from your failures than you do from your successes. We all know that.
So it seems to me, if you were having a conversation with somebody that you were trying to convince MBSE is what they need to be doing, they need to go full bore into that. It seems like what you've been saying, they would be seeing the light, that they would go, well, the fact that we're not doing this already blows my mind. I mean, but do people still have to be persuaded? Do you still have to show them or talk them through why they need to go to to the best way of doing things now?
To some degree, it's almost now it's gotten to be, it's not if, it's when and how.
Yeah.
There are competing tool sets. I think the industry enjoys a more stable investment environment. If it's going to invest in processes, tools, and knowledge, training of its people, it wants a more stable environment to exercise that in. And we have quite frankly, there are a lot of varying approaches to model-based systems engineering, to the tool sets that we employ, and that in itself is a impediment to proceeding.
Okay.
Because the company industry has limited resources, and they have to decide. So that decision process is a difficult one. If they decide the wrong a direction that the industry goes in another one, if they invest in, I won't use any particular, but if they invest in these tool sets and industry wind up not being the winner, then they might have gone off in a useful, but still in not the most advantageous direction for their let's take it a step. If a company, and you saw this, I saw it happening over many years. A company goes off and invests in a tool set in systems. My company invested in Intergraph and went off into the what did we call it? Anyway, in the CAD world, into those workstations, and invested in that. There were other companies that invested in. There were competing systems. Sabre was one of them, I recall, and many of the other CAD systems. And there were a number of other that invested in. And the customer, we're all going after a set of federal customers, let's say, and the customer said that we really wanted it in this. And if you were in one and System A, and you were invested in System B, you've got a problem. You've got a problem, and that happens. So I think that we know. Engineers know, and the companies know that digital engineering is not only useful, it is the way that we will develop systems, and we are developing systems. Model-based systems engineering is a subset of systems engineering. It will be. This is the digital representation of the design solution to be used throughout the life cycle. We're going to use that. We're going to do that. We all know that's the way we're going to develop systems and maintain them throughout their life cycle. We all know that. The process, we're now in the process. We got to define on what that's going to be, and where I put my money. Where am I going to put my training? Where am I going to put my money?
Okay, and that's
so that's an interesting problem to have. We will settle in on. There will be market leaders. We will settle in on these solutions. But I think even the process, no matter what tools you select, you're better off. I mean, that's a fundamental truth.
So it's coming.
Yes.
And maybe there are a few there are little side directions that are being taken, but ultimately, the all digital model-based systems engineering, that, as you just said, that's where we're going.
Oh, absolutely.
Absolutely.
100%. 100%.
All right. I'm sure there's about 15 other things I can ask you, but you have to go consult.
We have to earn a living.
Well, thank you so much for being with us.
Thank you, Steve. I've known you forever, and I enjoy our friendship. I really do.
I enjoy it. I enjoy knowing really smart people. You're smarter than I didn't know some of this stuff that you did.
That's the tip of the iceberg, my friend, but not from the smartness standpoint, just from the experiences standpoint.
Well, that's cool, though, that you've gotten as much and paid us all back, too.
I try, Steve. Thank you.
All right. Thank you, Joe Fitzgerald.
God bless you, brother. Appreciate you.
Thank you. Thank you, and thank you for being with us. And don't forget, it works.